That was feasibility study. On average, it takes us about 2 months from idea to know exactly what we are working on. Next step is engineering prototypes. This is the most intensive process for entire product development. So, and it followed by their engineering validation test at the end. Core goals on this stage is to validate all components. There is no tool involved, no cost optimization, and unit cost is usually high. It's a time when your first-time customers can fully understand the product. It's best time to raise money from investors, and you usually create up to 5 prototypes which can be shown to potential customers. I'm going to show you a case study which we're going to be discussing later on. This was their adapter for Microsoft Software Keyboard, which was making, you connect this one to the keyboard and you can use it wirelessly. So for that project, we create up to 5 prototypes. We all started with just the wires on a table, coming with the evaluation boards and some magnets, coming with followed with a PCB in a simple 3D printed enclosure, and then we compressed all of this into the final shape for device and created good-looking prototypes of final shape and functionality. On average, it took us about 4 months to create all those iterations. Typically, you expect anywhere from 2 to 3 iterations of PCB design during prototyping. It's fine to have some. Wiring as long as device does its job. Another recommendation I have for this phase is to add complexity gradually. There is no benefit of over miniaturizing device from the early on. It's going to be very hard to troubleshoot. So start big on evaluation board and eventually get smaller and validate components, validate schematic, and then make it final shape. This way, you don't waste time if something goes wrong early on. Okay? So, as I mentioned, it's okay to use some additional wiring on the prototypes as long as they're functional. There is no need to be pretty here. The goal is to make it work. Few recommendations for electrical designs. So, at EVT, forget about Raspberry Pis. They're nowhere near to be used in a product. So, use evaluation boards instead if you need to. Use pre-certified modules where possible. They allow you to simplify your product development and streamline your compliance. And finally, if your email doesn't end with apple.com or another big company, don't plan to use Qualcomm, MediaTek, and Realtek. They are really painful to work with, even to get some prototypes. A few more recommendations for electrical engineers. Check lead time prior to selecting parts. It's especially important in 2022. Most of our designs are driven by availability, not by the functionality. It's a hard truth these days. Some components which are really hard to get these days are STM32, Texas Instruments. We switched them for ESP32, Nordic and RF52, and some Atmel components. And finally, learn how to use Chinese alternatives. Many of those companies have pin-to-pin replacements which perform the same as TI, but they are much easier to get these days.